Deep's mission of making humans aquatic really resonates with me, and I feel it when I'm here in Vanguard.
When you have an underwater habitat like this, you're in the environment. You have immediate access. This is when you say, oh my gosh, I'm actually living underwater. This is completely different than anything that's out there.
Can you walk us through what each different room looks like?
Out the back end is the moon pool. I mean, that is the coolest place of all in Vanguard. That's your way in and out. You can swim down from the surface, come into Vanguard. You're no longer a diver, you're an aquanaut.
So what's it like to have ocean creatures as your neighbors?
Literally, when you get dressed out and are going out to make your dive and go to work, you actually have to kind of, say, hey, can you move over so I can kind of get out and do my job?
So they're nosy neighbors.
Yeah, they're nosy neighbors, and it's almost like you actually become part of that ocean environment.
Welcome to this New Scientist Collab podcast, sponsored by Deep and brought to you from an extraordinary location. We are inside Vanguard, a next-generation subsea human habitat designed to operate on the ocean floor. I'm Sophie Bushwick, and I'm here with two representatives of Deep, the company that has built this incredible machine. Norman Smith is the Chief Technology Officer, and Roger Garcia is the Director of Habitat Operations. Thanks for being here.
Thanks for having us.
Yeah.
And just to paint a picture for our listeners, we're in this long, narrow room with metal walls. There's portholes dotted around it. Norman, can you describe the Vanguard habitat where we're sitting?
So we're sitting in the living chamber of the Vanguard habitat. This is where a crew of 4 can live and work comfortably for a week or more. If you go aft that way, you step into the entry lock. One more hatch further and you're into the wet porch, which has the moon pool where you can swim in and out of Vanguard.
And I've actually been through those hatches to get in here. It's sort of like you really have to crawl through. It's like almost like being on a space station.
With practice, you get good at it.
Yeah, I imagine so. And Roger, maybe you could talk about Vanguard's purpose and as a home and laboratory for aquanauts.
Sure, yeah. So that's the goal of the company, right? To have these underwater habitats, not just in one place, but the vision and the goal is to have them in different locations, right? But as far as for the research part of it, right, the company's also focused on oceanographic research, and that part of it, the researchers are going to have basically immediate access to the underwater environment. That's a big plus for this type of scenario, right? Rather than being on a boat or having a saturation diving system that's also on a boat and you have to lower a bell and everything. This is, you live here, you're right where your work area is, and you literally just have to walk 30 feet and you're right there in the water and working. So that's the big thing about this.
Right. So when aquanauts don't have access to a habitat like this, like how long does it take them to get to where they need to be?
Yeah, and that's a really good question, because think about this, right? If let's say your research area is, and I'll keep it simple, just 10 miles offshore, you still have to take your boat, maybe trailer it to a launch ramp, get in, drive it out 10 miles, get ready, do your dive, come back up to the boat, you're done for the day, come back in, right? That's like a lot going on, right? Just to make 2 or 3 dives, right? When you have an underwater habitat like this, once again, you're in the environment, you have immediate access, right? And what we like to say is that this gives you the gift of time. So once you're saturated to this pressure and whatever breathing medium you're using, basically you can go outside and dive for up to 9 hours a day, depending on your deployment site and everything. So it's completely different than that previous scenario we talked about, going to a boat, on a boat and everything.
Right.
You might get 3 hours worth of work by making 2 or 3 dives from a boat on the surface, but here you're just going to get 9 hours of work. I mean, that's huge. We've had scientists come back to us and say, hey, a 10-day mission in the underwater habitat literally is equal to 6 months of research off a boat. Yeah. And that's huge for them. Huge. Yeah.
So Vanguard is not the first underwater habitat for humans. Can you walk me through the history of this type of habitat?
You can take this back starting in the late 50s, actually, with the Genesis project. It started with the U.S. Navy. So the U.S. Navy was the first one that proposed saturation diving, which was really spending long duration at greater pressures, basically living at these greater pressures, right? And doing work outside in the water column for long periods of time. From there, the first habitat that was built was around 1962, which was a conch shelf with Jacques Cousteau. And then from there, literally, there's been over like 60 habitats, but primarily, fast forward, if you will, about 3 or 4 really famous, important habitats, and some of those, of course, were the conch shelves. There was Sea Lab from the Navy. There was also the Helgoland, the German habitat, Tektite as well, and then Hydrolab, which was funded and built by NOAA and the U.S. government. But then from there, transition and came the Aquarius. Those 2 last habitats have been around for about 55 years. So they've been around for a long time. What is good, and this is speaking for me from the personal perspective. I love this, right? There's a soft spot in my heart for this. I really believe in this, and I was starting to worry that because I was seeing a decline in the use of the habitat. And now here comes Deep, here comes our company with this vision to make humans aquatic, right? And give easy, quick access, to humans, the ocean to humans, right? So I'm all excited again, because I really thought we were heading towards the end, but here we are with this, and it's built, right? It's got a little bit more to go, but it's almost there. It's going to be deployed. It's going to happen. So to me, we're picking up on a legacy that goes back for decades, right? That a lot of people really thought was going away, but it's not. We're here, we're coming with this new habitat, and, even, with a broader vision, Norman's got that engineering part where he's going to build something even greater, in the near future from, what we learned from this pilot habitat.
And we've got these metal walls. Obviously, the hull is very important. Norman, can you get into more detail about the engineering it took to put this place together?
Well, there's a lot of engineering that goes into a system like this. These steel walls you see in the acrylic viewports, this is our barrier to the ocean realm. But most of the time we're at ambient pressure, so there's very little pressure difference between inside and out. It's only occasionally when we come in here and do decompression at depth, Roger can tell you more about that, or we need the ability to withstand full atmospheric pressure differential with the outside world.
What's good about that is once we're done with the mission, right? It doesn't matter if the mission was 5 days or 30 days. The good thing is once you're saturated, the decompression is the same. It doesn't increase or anything like that, even if you stayed longer, right? So with respect to decompression, what's good about this is that you can do it in an environment that is controlled, right? It's climate controlled. Your occupants or aquanauts can lay down when they're breathing oxygen. You can keep them hydrated, keep it at the right temperature. What that does physiologically is it lowers the risk for decompression sickness.
And when this habitat is at depth, what sort of engineering went into, designing the shape, designing the thickness of the walls to make sure, obviously, that the people in here are going to be safe?
Well, I have a whole engineering team, a team of gifted engineers that designed every aspect of this system for the environment. Everything from the thickness of the acrylic on the windows to the thickness of the steel on the wet porch, on the stern end. Right. And the systems that are distributed throughout Vanguard habitat. We have power, we have gas systems, and livability. This very comfortable space that we're sitting in here. Every inch of space inside Vanguard we try to make good use of. So it's a comfortable stay for them to live and work. And we have a saying that we want our customers to come enjoy Vanguard, and when they leave, we want them to immediately want to come back.
Yeah, amazing. And Roger, you know what it's like to live as an aquanaut. So, can you tell us what it would be like to live down here for days or weeks? What are the biggest physiological and psychological challenges that the crew who will call Vanguard home would
Sure.
face?
Yeah, so one of the first things is once you actually come down here and let's say things get going, but then you have that one moment where you realize where you're at, right? So this is when you say, "Oh my gosh, I'm actually living underwater." This is completely different than anything that's out there, right? You're living underwater for one. The other part of it is with the physiological aspect of it. The biggest risk is the decompression sickness, right? But we have protocols in place where the temperature's controlled. Well, we can deliver oxygen during decompression, and we make sure that people during the day, they're going to do a lot of hard work. I mean, physiologically, it's taxing on the body, working out there for hours in the water column like that. But we always want to make sure that people get at least 8 hours of sleep. We make sure they stay hydrated. That keeps the risk of decompression sickness down, right? And that's really the biggest risk is decompression sickness. From the psychological aspect, I mean, think about it. You're in a cylinder and you have to work with a team, people's, different personalities. So you have to learn how to work together, and you got to be able to get along to get the job done. So those are the things that, kind of come into play. Yeah.
And I mean, right now, we're not in space, we're not underwater, we are on land. But eventually, when Vanguard is installed, life support systems are going to be crucial. Norman, can you point out some of these life support systems and explain what they'll be doing to keep the team alive and well underwater?
So embedded in the Vanguard system are all of those life support systems for breathable air, for example, CO2 removal from the air, CO2 we exhaust. That direction is a CO2 removal system.
Okay.
There's one in each of the chambers here.
Got it. Okay.
But if you think about it, we need breathable air, we need power, and that comes to us from a surface buoy that's tethered nearby. So we send compressed air and power down to Vanguard. If there's ever an issue, we have redundant systems, so we can sever that and rely on secondary systems that are mounted directly here to Vanguard.
Okay, in case of an accident or emergency.
Exactly. We have 72 hours of life support built into Vanguard. And during that time, it's ample opportunity to bring out support vessels, to swim in, swim out, go through decompression treatment, all of the above.
And what about, isolation? Is it the idea that the team comes down here and then they're set for the term, or are they going to be communicating with the surface beyond that buoy you mentioned?
Well, there are communication systems built in. You may have seen panels with phones to the top side. And like I mentioned before, redundant systems, there's VHF radio as well. So there's constant communication with topside and a watch desk back at our base of operations.
And Roger, we can't see the moon pool hatch from this room, but it's all the way at the other end. And the goal is to let scientists exit and then enter through that, work for hours on the ocean floor and return. Give us a sense of the freedom that gives divers. What are they able to do when they have this extended period of time that they couldn't do?
Right. And that's that thing, that gift of time, right? And once again, I go back to that immediate access. I mean, literally, depending on the dive mode that the customer chooses to utilize, whether it be scuba, rebreathers, or helmet diving, it's up to them what they want to use, right? And we just facilitate that for them and train them in that diving mode. But once it's done, it literally, you could literally get dressed out in 15 minutes. That's all, and then you're out in the water column and doing your job literally that quick. And then, we may not see you for the next 6 hours, but we will be communicating depending on what the customer and client needs are. Sometimes we might have what we call, let's say, a way station. It could be 500 feet away from the habitat where their work site is or their research site is. And we can literally put basically an air bubble out there with communications and air, where they can come in and maybe even talk amongst themselves to say, hey, we need to do this differently. We forgot a piece of equipment, we got to come back or something like that. So that's that freedom. They can go out there and do the job for hours at a time and not be restricted with the typical no decompression diving that people try to stick to keep the risk low, which is literally, depending on the depth, it's about an hour's worth of work. That's per dive. That's it.
Can you give a couple examples of the type of work that people are doing, the type of research?
Yeah. So coral restoration and coral transplantation, that's a big focus right now, especially in the warmer climates, South Florida and stuff like that. And also sponge research. When they're out there, they can take corals, and they might have a support team that comes. We'll bring them out on the boat, and then they'll have some scientists that will bring the corals down to them, pass it off to the aquanauts, and then the aquanauts might use some epoxy and transplant them.
They literally just glue it down?
Just glue it down. And interestingly enough, though, it may be to an actual natural bottom structure, rock on the bottom, or composite materials where they glue the corals to the composite material and see how they grow. So so it's all about that kind of research. Yeah.
You've mentioned before the idea that this is almost a spacecraft analog, and sitting here sealed off from the outside world, that's very easy to imagine. So how does this environment, this capsule that we're in, serve as a high fidelity lab for understanding what it might be like on a long duration space trip? Imagine a space trip to Mars, for instance.
Again, I go back to the space analog, right? You have this structure right here that is similar. It used to be similar to the space shuttle, and it is similar to the International Space Station. You have the hatches that they have to go through and stuff like that. But I do want to point out, once again, you have that crew dynamic, right? You have to work with these other astronauts, right? And with my experiences working with NASA, they're very detailed, right? They have this daily plan, and it's timed. If you're not doing what you're supposed to be doing by 12 o'clock, they're on the comms and they're like, hey, you guys need to get on this, So there's that crew dynamic where it's like, hey, we have to work together to make sure that we get our job done. And an underwater habitat like the Vanguard gets them ready and prepared for those types of space missions, right? They'll be better prepared and ready for it.
And Norman, we are, like I've said, on solid ground. I feel very safe in here, but I'm not in a position of trusting it with my life the way that the crew is going to when Vanguard is installed underwater. So how have you tested the structure that we're in to give its future inhabitants confidence?
That's a really good question. So the engineering rigor that goes into building a system like this is design and extensive analysis. Finite element analysis is what we engineers use, and test. This chamber that you're sitting in has been drop tested off the side of a boat to a depth greater than the depth we'll ever use it, just to prove that it's safe for operation. Mm-hmm. All of these systems go through tests like that before put into service.
What is that maximum depth?
This Vanguard is designed for 50 meters depth. Mm-hmm. Our first installation will be at 20 meters depth, so we're well within its operational limits.
And you've dropped it even deeper than that during testing?
Yep, dropped it deeper than 50 meters, close to 70 meters.
So what's going to happen next for the habitat?
So we're here in Miami. This is the big debut of Vanguard. After this exhibit, we take it back to Triton Submarines in Sebastian, Florida, and we will put it through a whole series of acceptance tests. Every single system will get tested to prove that it's fit for service, and then we'll deploy it to ocean. Long before that has happened, individual components have been pressure tested. We've done what's called non-destructive testing of the pressure hull to prove that all the weld joints are good and fit for purpose. From one end to the other, Vanguard has been through certification testing.
And this habitat is also a stepping stone to the next generation habitat called the Sentinel system, which is going to be larger than Vanguard. So as you sit inside this creation, what are you already learning about the ergonomics and the layout and the technology that you think is going to go into building Sentinel?
That's a really good question. The ergonomics is huge for us. In fact, what you're seeing in Vanguard here is the result of 2 or 3 different design cycles that Roger and I have both been instrumental in affecting, me from an engineering standpoint, Roger from an operations standpoint. I may have mentioned before, we try to make the most use of every inch of space here in Vanguard. We have a saying where every bit of space, we try to make it serve 2 functions.
Okay. Can you give me an example?
Well, like these benches here,
Mm-hmm.
these comfortable, cozy benches.
Yeah, they're like sofas.
They flip up, and that's 4 bunks for the crew.
Okay. Yeah. Yeah.
Already, I can tell I wish I had more space to work with. This is comfortable and cozy, and we worked hard to make it that way. Sentinel is going to be much larger.
And Norman, right now, viewers can see the part of the living chamber, but that's not all that's in the habitat. Can you walk us through what each different room looks like?
So this is my favorite space in the living chamber, this very comfortable seating area. And we have this viewport to the ocean realm here. What you can't see, it's on the other side of the camera, is if you lean forward and look through the hatches, you get to see out the aft window in the wet porch. It's the largest window in the habitat. So that's my favorite view. You'll be able to see ocean realm this way and that way.
Okay.
But I'm going to walk you through Vanguard. We're sitting in the den area, if you will, very comfortable seating area. We have a pair of benches. They're configured as benches now. These flip up to form bunks for the crew 4. You go further aft, and we have a galley on the starboard side, like a ship, bow, stern, starboard, port, and a meal prep area on the port side. Before you go through the hatch, there's an air conditioning unit there that keeps the air cool. Our first installation is going to be in rather warm water, so our challenge is to keep the air comfortably cool in here. CO2 absorption happens there. In every compartment, you've got a power panel, a display, so you can see the systems, and a comm panel off on the port side. You go through that hatch, and you're in the entry lock. On the starboard side is the toilet. It's raised a bit, so we have nicknamed it the throne.
Okay.
And then there's surfaces there for working on equipment on the port side. I should mention the throne has a privacy curtain there, so you can do your business in private. Continue going through the hatch. An amazing piece of engineering I'm rather proud of. There's 300 parts to this hatch that seal
300 parts?
300 pieces.
Wow.
that seal this vessel from the wet porch, the diving center, which is always at ambient pressure.
Okay.
So you go through that trunk, through that hatch, and you're into the wet porch, and there's where you'll find the gas supply systems for the divers, especially if they're out on a hard hat. As Roger mentioned, you can dive out of the wet porch on rebreather or scuba. All of that equipment will be stored there, and out the back end is the moon pool. That's if it weren't for the windows, I mean, that is the coolest place of all in Vanguard. That's your way in and out. You can swim down from the surface, come into Vanguard. You're no longer a diver. You're an aquanaut once you enter Vanguard.
And what does the moon pool look like from inside Vanguard?
Inside Vanguard, it's a rounded rectangular opening in the floor. So you're looking down into ocean, and next to it is the largest window of all. So you're looking down into ocean and out into the ocean realm. So I can only imagine, Roger can attest to this, the ocean critters are going to be outside looking in.
Wow.
So we'll be inside the aquarium.
So what's it like to have ocean creatures as your neighbors?
Yeah, and it does happen, okay? Going back to what Norman was saying, that window that we have on the Vanguard, that is going to be awesome. I mean, people are going to love that simply because of what he just said. You're looking out the window, plus you're looking down, and you got ocean, right? So this is what happens. So as time goes on, and the sea life that kind of sees this out there, and they start hanging around, and they sort of start making it their home. That's what's going to happen. It's going to start making it their home. They literally like to hang out right under the wet porch, literally inches from the top of the water before they come into the airspace. And historically, we've had Goliath groupers as large as 400, 450 pounds, huge fish. They just like to hang out there. And literally when you get dressed out and are going out to make your dive and go to work, you actually have to kind of, say, hey, can you move over so I can kind of get out and do my job?
So they're nosy neighbors.
Yeah, they're nosy neighbors. And you know what's really cool about this though, is as time goes on, the habitat, the people that do the missions, it's almost like you actually become part of that ocean environment, and they look at you as really part of the neighborhood. That's really what's unique about this type of system, rather than the typical systems that are up on the surface, right? But yeah, the sea life, they kind of start looking at this as their home and a place to hang out.
For both of you, do you think that having that perspectives will shift how people see themselves in relation to the ocean, from visitors to maybe guardians?
Yeah, absolutely. Let me just real quick, just to say, historically, one of the biggest things that is good as far as having a system like this, and the Vanguard is going to do it too, we're going to do it as well, is education outreach for the public, right? And a lot of people don't get to come into the habitat. It can literally be a once in a lifetime opportunity. And I'll give you an example. The Aquarius habitat, we worked and done 153 missions over the last 38, almost 48 years. And we only have about 450 or 70 aquanauts. That's not a lot of people, right? So the public doesn't get a chance to see this. So being able to do things like education outreach, link ups with children in classrooms, in a state that maybe just has lakes and doesn't have oceans, or doesn't have any lakes or oceans, that's very important to engage the public like that, to help get them engaged to get into, helping protect the ocean and take care of the ocean.
Deep's mission of making humans aquatic really resonates with me, and I feel it when I'm here in Vanguard, and the wet porch and the moon pool we talked about and the big window. I mean, you're right there. You're living in the ocean. That's ocean. You're in and out. And this is our pilot habitat. We're not going to build just one habitat. We have a vision to build many habitats, even clusters of habitats, and now you have to be aquatic to go from one habitat to another. And that just is, to me, I think that opens a whole new world of understanding and appreciation and yes to that vision of making humans aquatic.
When Vanguard is actually on the seafloor, what's the first image or piece of data that you're hoping to see that you think will make all this effort worthwhile?
Yeah, so we have plans to do our first mission, right? Which is going to be a science mission. And we're in the planning stages of choosing a crew that, that they'll have their own little specialty. So it's going to be multidisciplinary. But it is going to be, related to oceanographic research. But we're also trying to do a little bit of physiological research too. I'm kind of excited about that one because I kind of like the diving part of it and decompression. What is the body really doing? How many bubbles are really forming when you're doing decompression in the Vanguard with our decompression model? So that's going to be our first mission. It is going to be a science mission. Yes, we have a focus mainly to do oceanographic research, but there is going to be also a physiological component as well. And I'm kind of excited about that one. Yeah.
For me, validation of Vanguard and our approach to building habitats happens quickly once we install Vanguard in the ocean. First occupants here will have lots of feedback for us engineers, and that's when the clock starts for us on the next system to build in the roadmap. So the minute Vanguard is wet and installed and in operation is, first off, incredibly exciting, but validating for us and the start of the next build.
And that's all we have time for. Thank you, Norman and Roger, and thank you to our sponsor, Deep, and to all of you for listening. I'm Sophie Bushwick, and you can listen to this and other stories from New Scientist Collab wherever you get your podcasts.